All right, so this is our last one. And so on each of these, we've been looking at trying to find a certain area. So we're just looking at what sectors do we add up, and we need a starting and a stopping value, and which polar curve or curves are we using. So this one, we're going to be taking r equals 1 plus cosine theta and r equals 1 minus cosine theta and finding the area that's in both. So I'm going to use Desmos. You can use your graphing calculator as well. But I've already got it graphed. I've plugged them both in here. I have 1 plus cosine theta and 1 minus cosine theta. And then as I move this around all the way to 2 pi, you can see that we get these two regions that are the area in between. So what we're looking for here is if you were to look for the red here, this one right here, this would just be the red. You can see those are the red sectors adding up. And over here would be just the blue. And this would just be the blue. And this would just be the red. So what we just really need to know is where do we start and where do we stop to get these? And so what I'm going to do is just back this up because it's the simplest back, and I like 0, so from there to there. So if I go from there to there, you can see I get one of them that I can then quadruple. So if I take finding the area of this one and multiplying it by 4, I get what I need. And I don't need the blue sectors. I just need the red. So the red sectors from 0 to whatever that is, just focus on the red right now, that's it, would give me the area of that, and then I can quadruple it. So what I need to know is where do they intersect? So it looks like if we finish this that we have 3 points of intersection. Let's find out what we have. So if we set these equal, add the cosine theta over, I get 2 cosine theta equals 0. So basically cosine theta equals 0. And this occurs when theta is pi over 2 or 3 pi over 2. That's when we get 0. So going back, it looks like we have 3 points of intersection, but we only have 2. So if you look at it as we go through it, the red and the blue both hit there. That's a point of intersection. Down here, it's not. So at 0, it's not a point of intersection because that one's at 0, that one's at 2 for the radius. And then as we keep going, you can see at 3 pi over 2, yes, they both hit. So all I need to do is go from 0 to pi over 2. So like this. So if I go from 0 to pi over 2, it'll give me that first quadrant thing. So I need to set this to pi over 2. I think I said 3 pi over 2. I meant pi over 2. And you can see it's going to give me that region. And I don't want to even include the blue. The blue is going to give me too much. And if I subtract them, it would give me this region. And we're looking for the area between both. So if I find that one, I can quadruple it to make the 4. So from 0 to pi over 2 with just the red, which is my 1 minus cosine theta. It's this guy. So what I want is just that red region here, right there in those sectors that added up from theta equals 0 to theta equals pi over 2. So if I do integral from 0 to pi over 2 of 1/2, and then I do r, which is 1 minus cosine theta squared d theta. I don't even need the other one. So I'm not using the subtraction. I'm using the area of a polar. Just because you want an area that's in both doesn't mean you're going to use this one. You could just be using this one, which is what I'm doing. So this is just the 1 minus cosine theta that I'm using. Okay. So now I need to do 4 of these, though, because, again, I got to do that one, and that one. So we have 4 of them to do, which is nice because then it cancels at 2. So we have 2, 0 to pi over 2, and then I'm going to multiply that out. So I'm going to distribute that 2 because I know inside there I'm going to end up with, I don't need the parentheses now. I'm going to end up with a half with that cosine of squared. So I know when I do my double angle on it, I can now just not even use it. The half, that is. Don't need it. So cosine squared would be 1/2 1 plus cosine 2 theta. The 1/2 and the 2 cancel. So now I can go, well, that's 2 plus 1 is 3 minus, I'm going to need more room than that, 3 minus 4 cosine theta plus cosine 2 theta d theta 0 to pi over 2. All right, so we have 3 theta minus 4 sine theta plus 1/2 sine of 2 theta. All right, and the sine doesn't like 0, so that's perfect. So we have 3 of pi over 2 minus 4. And then minus, plus, minus. Okay, so we have 3 pi over 2, and then sine of pi over 2 is 1, and sine of pi is 0, so we don't have to write it. And then we get 0, 0, 0, everything is 0. So we end up with 3 pi over 2 minus 4 for the exact value. Now let's verify this in our calculator to see that it's correct. And there it is. They're exactly the same value. So when you're doing the area, sometimes you may have to subtract them. So if they had asked for this region here that is inside this curve, but outside that curve from 0 to pi over 2, then we would subtract them. But it didn't. It asked for just this region that they have in common. So if I go all the way around, oops, wrong slider, all the way around like this, you can see that we get those 2 little leaves here. So we're just going to go and find that red one. So we could have also found the blue one, right? And so the blue one is being made from pi over 2 to pi, or the next blue one, which is from pi over 2, see, to 3 pi over 2. That would work. Or we could have continued and found that one, but it was just easier to start with 0.